Hello friends, welcome to our channel Anand Academy of Education. Today we are going to start a new chapter, Vector Algebra. This chapter is very essential and important for intermediate, Eamcet, JEE or any other engineering entrance examination because there will be at least one question from this chapter in any exam, intermediate, Eamcet, JEE or any exam, any other state engineering entrance exam. So this is our first lecture and let's get started. Scalars and vectors. So this is the very fundamental concept that we need to know. So the first and foremost thing in vector algebra is to know about what is a scalar and what is a vector. So a scalar is something or a physical quantity that has magnitude but no direction. A scalar is a physical quantity that has magnitude but no direction, whereas vector has magnitude and direction. Vector has both magnitude and direction. For example, let us take a person X and let us take a person X. This is north, this is south, this is 5 kilometers, this is also 5, this is east, this is also 5 kilometers, and this is also 5 kilometers. So this person X, if I say the person X traveled a distance of 5 kilometers, person X traveled a distance of 5 kilometers, then his travel could be either towards east or towards north, towards south or towards west. It could be any direction. But since I just told you only the number 5, I said the person X traveled a distance of 5 kilometers. Then it is not clear that in which direction. So this is a scalar quantity because I did not say direction, but I only told you about the magnitude. The magnitude here is 5. So this becomes a scalar, distance. So this distance becomes a scalar. But if I say the person traveled 5 kilometers due east, but if I say the person X traveled 5 kilometers due east, so here I told you the magnitude and also the direction. The direction is east. So now this becomes a vector. And we call this displacement. Distance is a scalar quantity. Whereas displacement is a vector quantity. So this displacement has both magnitude and direction. Whereas distance has got only magnitude. So if I say the person X traveled 5 kilometers due east, in the east direction, then this becomes a vector quantity. Now let us look at some of the examples of scalars. Distance is a scalar quantity because it does not have any direction. Just as we discussed in the earlier slide, distance doesn't have any direction. It has got only magnitude. Likewise, similarly, mass is also a scalar quantity. It doesn't have any direction. Likewise, temperature. If I say 30 degrees centigrade, does it have any direction? No. It only represents magnitude but not direction. It has got only magnitude but no direction. Likewise, energy. If I say 50 calories of energy, does it have any direction? No. It doesn't have any direction. So energy is also a scalar quantity. Likewise, time. Is time a vector quantity? No, because time doesn't have any direction. It is only it only represents a number, and so this time is also a scalar quantity. These are some of the examples, and there are many examples of scalars which we will not be discussing here. Also, we will not be going into the definitions of these terms, because this is a math class, and we don't need those definitions in our math class. We'll be looking into those definitions in physics classes. And now, examples of vectors. These are some of the examples of vectors. Displacement. Displacement is a vector quantity because it has magnitude and direction. It has magnitude and direction. Let me also tell you something. We can say distance as 5 kilometers, but we cannot say distance as minus 5 kilometers. Distance as minus 5 kilometers, because this is always positive, whereas displacement can be positive, negative, or even zero, because displacement is a vector quantity. So if I say, let us take these 2 points A to B, the distance from A to B is 5 kilometers. This is plus 5, and from A to C, this is backward direction. This backward direction is minus 5. So here this minus represents the direction, whereas this plus 5 represents the direction. So displacement is a vector quantity. Velocity is also a vector quantity. Acceleration, force, weight, momentum, these are all vector quantities because they have magnitude and they have direction as well. Now, vector representation. So how do we represent a vector mathematically? So first, let us write the characteristics of vectors. So first, vectors have magnitude. Number 2, vectors have direction. So how do we represent a vector mathematically? This is a line, and this OA is a line segment. Now this is not a vector quantity, but if we add a direction to this, then this becomes a vector quantity. So how we represent this vector is like this. OA, the starting point of the vector and the terminal point of the vector, and we mark a arrow point above these two. This is the direction. So this means that this is a vector from O to A. Likewise, if we want to write this vector, okay. Likewise, if we want to represent a vector in the negative direction, so this is positive and this is negative. So how we represent this vector is AO. So the starting point here is A and the terminal point here is O. So we represent this vector as AO. The starting point is A and the terminal point is O. So the vector is going from A to O. So this is how we represent a vector. Also, we can represent vectors using small letters as well. So we can represent this OA vector as A bar. We can just represent this vector as A bar or B bar or anything. We can just represent this vector using small letters as well. So we just read this as OA bar. Usually we just read this as OA bar, OC bar, A bar, B bar, etc. So a vector is represented by its starting point and terminal points. So this is A, this is B. So how do we represent this? We represent this as AB bar. AB bar. The starting point is A and the ending point is B. So we just represent this vector as AB bar. So the vector goes from A to B. Starts from A and ends at B. So a vector is a line segment. A vector is a line segment. In short, a vector is a line segment having a direction. So a line segment has got magnitude OA. So there will be some distance between O and A. O and A. So this is magnitude, and now it has got some direction. It may go from O to A or A to O. So a vector is a line segment having a direction, having some specified direction. So this is how we represent a vector mathematically. Now position vector. What is position vector? So first, what is this? If we add direction, this is AB bar. Likewise, if we take coordinate axis x, y, this is z, and if we consider a point P in space having coordinates x, y, z, and this is origin, and if we OP bar is a vector. So OP bar is called a position vector because we here are representing the position of P with respect to O. This is OP bar. This is a position vector. Because here we are representing the position of P with respect to O. So if we represent a point in space with respect to origin, then that vector becomes a position vector. If we represent a point with respect to origin, then it becomes a position vector. Here AB is not a position vector because we did not represent B with respect to origin. A is some point in space. But A is not origin. But if A becomes origin, then this becomes position vector. Likewise, if we take Q, so this OQ bar is also a position vector. This is also a position vector. Because here we represented the position of Q with respect to O. So this OQ is a position vector. So if we represent a position of a point with respect to its origin, then it becomes a position vector. But AB is not a position vector because the point A is not origin. So this is how we represent a position vector, and this is what a position vector means. And just like how we represent this AB bar in small letters like A bar, B bar, and so on, we can also represent this OP bar in small letters. Or OQ bar is equal to B bar. It is not mandatory that we need to take OP bar as A bar always. We can just take any small letter. So this is only for representation purpose. It is not necessary that we need to represent OP bar as A bar. We can just represent OP bar as Z bar and so on. All right. So this is how we represent vector, and this is how we represent a position vector. And this is it for this class. In the next class, we will be discussing the types of vectors. Okay, and thank you for listening, and